Okay, so we're going to get started on this I do, which is how to calculate the empirical and then the molecular formula. If you have not watched the video that I posted that explains the difference between the empirical and the molecular formula, and how, if you know the empirical formula, how to find the molecular formula, then you really should do that. And that video should be linked there on your Google Classroom for you to find. So I'm going to start working through some of the problems here for you, or this problem for you. Let me get my pen to working. And so first off, this is sugar is used in treating patients with low blood sugar. Has the following chemical composition: 40% carbon, 6.7% hydrogen, and 58.3% oxygen. What is the empirical formula? And if you'll remember, we've already done percent composition. So we've taken and gone the opposite direction, where let's say we had sodium hydroxide. I think that was one of our problems. And we wanted to find what percent sodium was of sodium hydroxide. And so it was always the percent over the whole on that. So this has already given you the percent. So we're going to write the formula. Now, let's just talk about an example of a formula here. If you have, let's say, H2O, okay, I'm just going to use an example here. Then if I'm looking at this, I would have 2 moles of hydrogen for every 1 mole of oxygen. Where if I have H2O2, hydrogen peroxide, this tells me I have 2 moles of hydrogen for every 2 moles of oxygen. And so by writing this as what we call a mole ratio, we can actually find the empirical formula. So let's just get started, and I'll show you some. And then also, if you need more examples, I have posted several different videos on here of me working empirical and molecular formulas. So there's quite a few different examples you can look at on there. So let me go ahead and get this off of there and get started. So the very first thing to do is, if they give you the percent, again, we're thinking of it as, okay, if I had 100 grams, then 40% carbon would mean I'd have 40 grams. So that's where we're going to start. Now, this is kind of my setup of how I like to do it, kind of in organizing my data. So I do carbon, hydrogen, and then oxygen. And the very first step, so step number 1, is to change it from grams to moles. So our first step is to go from grams to moles. So that's why I had you back up and do that extra assignment to get from grams to moles. So let's just go ahead and set up. I'll go ahead and try to organize it into the railroad tracks. I'm not super good at drawing my straight lines, so I will try to do that. So again, we have 1 mole of carbon is 12.00 grams of carbon. Again, my grams are going to cancel. And so when I multiply across, I have 40 divided by 12. And grab a calculator here. You guys can go ahead and do that and get your calculations done. So we're going to go ahead and take 40 divided by 12. And you want to round it to 3 significant digits. So in my case, I have 3.333 repeating. And so the answer here would be 3.33 moles of carbon. Okay, and then we're going to repeat the same thing with hydrogen. We're actually going to do 3 gram to mole problems. So our next one is 1 mole of hydrogen, again, was 1.01 grams of hydrogen. Unit cancellations. And let's do that. 6.70 divided by 1.01. And that is 6.63 moles of hydrogen. Okay, and then we'll do the last one real quick. So again, we're going, oops, that should have been grams. Didn't change it. So let's see. I left my periodic table at school, so hopefully I get this right. Oxygen is 16, I believe is what your table reads. So the grams of oxygen are going to cancel, and again, we're going to divide that out. So 53.3 divided by 16, and it is 3.33 moles of oxygen. Okay, so there's our first step. So we take and write everything and change it from grams to moles. And the reason why we go to moles is because since everything weighs something different, by changing it to moles, now we have something that they're all exactly the same. If I have 3.33 moles, I know exactly how many atoms that would be, and so forth. So that's why we have to go to moles. It's a consistent comparison, I guess you would say. And so the next step that we're going to do then is we are going to divide by the lowest number of moles. Okay, and that's just to get the ratio of all these. That's all we're doing, is trying to find the ratio. And so in order for our ratio to be whole numbers, or not all decimals, just to say, we're going to divide all the time by the smallest. And so one of the things, and I know it was an issue last year, because kids would come out here and they would say, well, this equals, and then I would divide it out. Well, guys, it does not equal, okay? What you're starting right now technically is another whole set of problems, okay? So don't write equal. That's the math, I guess, in me. If you put equal out there, I'm going to say, or I have kids who just write here. They'll just, right underneath here, they'll start dividing by the smallest. Don't do that, because, again, this problem should be a standalone problem. Now we're going to the second part of the problem. And so we're going to take and we're going to divide by the smallest. So I'm going to take 3.33 moles of carbon. And really it's just a mole, so we're just doing the mole ratio. And since moles of oxygen and carbon are the same, and at this point you can really leave, we don't really care what necessarily as far as putting on a label, so you could leave that piece off. And I'm going to divide it by 3.33 moles, again, because I'm dividing each by the smallest, and these two are the same, so technically they're both the smallest. So this one would be a 1, 6.63 divided by 3.33 moles, and again moles. So these are really just kind of canceling out the mole unit. And so if you want to, you could just leave that off, because we're dividing moles by moles. So what I'm saying is it would be acceptable if you didn't put this on here. Matter of fact, a lot of times in the book they don't even put the labels, because we're doing dividing by itself, if you want to say. So I'm going to just slide that on over. You can leave it on there if you did. I just wanted to show you that you could. So this is probably 2, but let's divide it out, or close to 2. 6.63 divided by 3.33. So it's 1.99. Now, since it's 1.99, we can just call it 2. That's close enough. We'll talk about if you have some that are very close to 0.5, if you have some that are close to 0.3, then we have to work those a little different. But that one's close enough. It was 1.99 that I could say it's close enough to 2. Okay, and then this one would be 3.33 divided by 3.33. which is 1 again. So what these values over here are telling you, okay, what these values are telling you is those are your subscripts on here. So it is saying I have the ratio of 1 carbon to 2 hydrogens to 1 oxygen. So that would be my empirical formula. Okay, that is your empirical. Now, do you need the ones on here? No, you don't. But I put them on there to show you where I get the numbers. Okay? So that is how you calculate out an empirical formula. Okay? I'll stop this video and then do problem 2 on the next video.